In this video, we're going to talk about when function is increasing and decreasing. Let f be a function defined on an interval I, and let x1 and x2 be any 2 points in interval I. You know that f is increasing on interval I if x1 is less than x2, which implies that y value of x1 is less than y value of x2. And we know that f decreases on interval I if x1 is less than x2, which implies that f of x1, the y value of x1, is greater than the y value of x2. So graphically, look at this function f. You know that this is increasing. By the way, when we talk about increasing and decreasing, you need to look at it from left to right. Left to right. So here, x1 is less than x2. When the function f is increasing, y value of x1 is less than the y value of x2. When function is decreasing, and notice x1 is less than x2, the y value of x1, however, is greater than y value of x2 when function is decreasing. Again, when we talk about increasing and decreasing of a function, you have to look at it from left to right. So what happens when f is increasing on interval a to b? That means f prime, which is the slope of f, will be positive. And when f is decreasing from interval a to b, that means f prime, the slope of f, will be negative. So basically when function f increases, f prime will be positive, and when function f decreases, f prime will be negative. And now we need to talk about first derivative tests for local or relative extrema. At a critical point C, if f prime changes sign from positive to negative, which means f was increasing to decreasing, because f prime changes from positive to negative at C, where f prime is greater than 0, for x less than C. Whenever x is less than C, f prime is positive. And f prime is negative when x is greater than C. Then f has a local maximum value at C. Notice, when f prime is positive, that means function is increasing. And when f prime is negative, that means the function is decreasing. Therefore, you're going to have a local maximum at C. Over here, also is increasing and then decreasing. Only difference between these two is that f prime of C is equal to 0, because you're going to have a horizontal tangent line at x equals C. But over here, f prime of C will be undefined, because you have a cusp. Now, how do you know when we have a local minimum or relative minimum? Well, that happens if f prime, the slope of f, changes sign from negative to positive at C. Because when f prime is negative, that means f is decreasing. And then when f prime is positive, that implies that f is increasing. Same over here. F prime is negative, therefore f is decreasing. And f prime is positive, so f is increasing. Again, only difference between these two is that f prime of C is equal to 0. However, you also have to concern about when f prime of C is undefined, because the relative or local minimum or maximum could occur when f prime of C is undefined as well. Now, there could be a case when f prime does not change sign. So for example, over here, you know that f prime of C is equal to 0. However, f prime is positive before C, and after C, f prime is positive as well. So which means that it will be increasing. So there's no relative min or max. What about over here? F prime is negative. That means f is decreasing. At C, f prime of C is undefined. And f prime is negative after C, so this function is decreasing. So there's no relative min or max. Now, what about at the endpoint, A and B? Well, the local maximum occurs at A if f prime is negative when x is greater than A. So, for example, if f is decreasing after A, that means there will be a local max at x equals A. And local min will occur at x equals A if whenever x is greater than A, f prime is positive, which means f is increasing. And at right endpoint B, there will be a local minimum at B if f prime is less than 0 for x less than b, because that implies that f is decreasing. There will be a local maximum at b if f prime is greater than 0 for x that is less than b, because that implies that when f prime is greater than 0, that implies that f is increasing. Where is the function f of x, x cubed minus 4x, increasing and decreasing? So in order to find the intervals when f is increasing and decreasing, we got to find the first derivative. We're applying the first derivative test. So f prime of x is equal to 3x squared minus 4. And we got to set it equal to 0, because we're trying to find the critical points. So now what you're going to do is you're going to solve for x. So you get 3x squared equals 4. So you get x equals positive negative square root of 4 over 3. And this is the same thing as positive negative 2 over radical 3. So these are our critical points. Now we're going to draw a first derivative chart. Notice I put f prime, and let's put the critical points. You got negative 2 over radical 3 and positive 2 over radical 3. Now what we need to do is we need to plug in values to f prime and see whether f prime is positive or negative. So what would be a good number to choose from here? 10. Let's plug in 10. Make sure you plug it into f prime, not f, because this is f prime chart. So when you plug in 10, you're going to get positive. What's a nice number to choose from here? 0. When you plug in 0, you get negative. What about over here? How about negative 10? When you plug in negative 10, that becomes positive 100. So you end up getting positive here. So we know that f is increasing when f prime is positive. So f is increasing. At interval negative infinity to negative 2 over radical 3 and 2 over radical 3 to infinity. And f is decreasing when f prime is negative. That happens when the interval is from negative 2 over radical 3 to 2 over radical 3. Some books, they use a bracket instead of parentheses when they talk about increasing and decreasing. On the AP exam, whenever we talk about increasing and decreasing, and when we talk about intervals, it doesn't matter whether you use parentheses or bracket. So just keep that in mind. Now let's go one step further. How do we know where the local min and maximum occur at for f? Well, in order for local maximum to occur, we know that f prime has to change sign from positive to negative. So local max occur when x equals negative 2 over radical 3 because f prime changes sign from positive to negative at x equals negative 2 over radical 3. Now what about local minimum? We know that local minimum occurs when f prime changes sign from negative to positive. So local minimum of f of x occurs when x equals 2 over radical 3 because f prime changes sign from negative to positive. Now let's take a look at f of x equals x cubed minus 12x minus 5. So in order to find like local extreme values, or when f is increasing and decreasing, we need to find critical points. In order to do that, we got to find first derivative and find out when first derivative is equal to 0 or undefined. Now, since this is a polynomial, it will be defined everywhere. And we need to find when 3x squared minus 12 is equal to 0. So you end up getting 3x squared equals 12. So x squared is equal to 4. So we get x equals positive negative 2. Now we're going to draw the f prime chart again. So here are our critical point, negative 2 and 2. Let's choose a nice number that belongs here, which is like 4 or 5. It doesn't matter. And plug it into f prime. Make sure you plug it into f prime. And then you end up getting positive. And the nice number to choose from here is 0. Plug in 0, you get negative. What about over here? Negative 4 or negative 5, doesn't matter. You end up getting positive. So we know that this f, function f, is increasing from negative infinity to negative 2 and 2 to infinity because f primes are positive within those intervals. And this f is decreasing in the interval from negative 2 to 2 because f prime is negative. What about local mean and local max? Well, we know that local max or relative max at x equals negative 2 because f prime changes from positive to negative. So when they ask you to justify your answer, you have to say local max occurs at x equals negative 2 because f prime changes sign from positive to negative. And what about local min? Local minimum. It occurs at when x equals positive 2 because f prime changes sign from negative to positive. Again, you have to write all that out if you want to justify your answer. Now, what about local maximum value? How do you find local maximum value? The local maximum value will be f of negative 2 is the y value of f of x when x equals negative 2. In order to find it, you got to plug it into f of x. And the y value will be 11. So this is the local maximum value. What about local minimum value? Well, the local minimum value is going to be f of 2. Again, you got to plug in 2 to the f of x, and you end up getting negative 21. So that is a local minimum value. Now let's take a look at g of x equals quantity x squared minus 3 times e to the x. So if you want to find the local min and maximum values, you got to find the first derivative. We have to use a product rule here. So you get x squared minus 3 times the derivative of e to the x, which is e to the x, plus e to the x times the derivative of x squared minus 3, which is 2x. Now, notice you have a common factor, which is e to the x. So I'm going to take out e to the x. You end up getting x squared plus 2x minus 3. Now, you got to set it equal to 0. And this is factorable. So I'm going to say this is e to the x times x plus 3 and x minus 1. And you know that this goes to 0 if e to the x is equal to 0, x plus 3 is equal to 0, or when x minus 1 is equal to 0. Now, so we get x equals 1, or x equals negative 3. Now, take a look at this. E to the x, it doesn't matter what x is. E to the x is always positive. So this can never be true. Also, when you natural log both sides, natural log of 0 is undefined. It doesn't exist. So there is no solution for this. So we only have two critical points. X equals negative 3 and x equals 1. So we're going to come up with f prime chart. We're going to put negative 3 and 1. Now, this is the same thing as g prime of x. And I want to use this because this is already factor form. So let's choose a nice number here. 4, 5, doesn't matter. 10. Plug into g prime. I'm sorry, I made a mistake. This should be g prime, not f prime. So let's plug it in. Let's plug in 4. You get positive, and e to the x will always be positive no matter what x is. So it will be positive. What about over here? Let's plug in 0. Negative, positive, so negative. Now choose any nice number over here. Negative 5, negative 6, doesn't matter. So negative, positive, so it will be positive. So you know that g is increasing from negative infinity to negative 3 because g prime is positive. Also, g is increasing from 1 to infinity. And g will be decreasing when the interval is from negative 3 to 1. Now, what about local max and local minimum? Local max of g occurs at x equals negative 3. Because g prime changes sign from positive to negative at x equals negative 3. And what is the local maximum value? The local maximum value will be g of negative 3, which is going to be 9 minus 3 is 6 e to the negative 3, which is the same thing as 6 over e to the third power. And you could change it to decimals if you want. Now, what about local min? Local min occurs when at x equals 1 because g prime changes sign from negative to positive. And what is a local minimum value? It's going to be g of 1, which is going to be, now make sure you plug it into g of x, not g prime of x. You get negative 2 e to the first power, which is just negative 2e. And of course, you could change it to decimals if you want. Now let's take a look at this function. F of x equals x to the 2/3 times quantity x minus 5. Now, if you want to find the local min and local max, or to find out when f is increasing and decreasing, you got to find the derivative of f. Some of you might want to use product rule, but what I like to do is I like to multiply this out. I'm going to get x to the 5/3 minus 5x to the 2/3. Now I'm going to take the derivative. So I'm going to get 5/3x to the 2/3 minus 2/3 times 5, which is going to be 10/3x to the negative 1/3. Now we could factor this out. What is the greatest common factor here? Well, 5 over 3 and 10 over 3. Whenever you take out the coefficient, always choose the smaller. So you get 5. I'm going to take 5 over 3 out. And what about the variable? You choose a smaller exponent, which is negative 1 over 3. So this times what will give you that? It's going to be x. Check it out. This times x will be 5 over 3x to the 2/3 minus 2. Okay, this times negative 2 will give you this term right here. Now I could rewrite this as f prime of x is equal to 5 quantity x minus 2 over 3x to the 1/3. This is f prime of x. Now when does f prime of x goes to 0? It goes to 0. Let's set it up equal to 0. Equals to 0 when, okay, let's cross multiply. And equals to 0 when x equals negative 2. And notice that at negative 2, this is still, denominator is still defined. So we're good with that. Now, when is f prime of x undefined? It's undefined when the denominator is 0. So when is the denominator equal to 0? Denominator is 0 when 3x to the 1/3 is equal to 0. So you get x to the 1/3, which is equal to 0. You raise both sides to the power of 3, you get x equals 0. So here's another critical point. So you have 2. X equals 0 and x equals negative 2. So we got f prime chart here, and we got 0 and 2 as a critical points. So let's plug in the numbers to f prime of x and see what kind of sign we get. So you could choose any number that are greater than 2. Let's say 4, you're going to get positive. What about a number within between 0 and 2? Let's choose 1. You get negative and positive. So you end up getting negative. What about over here? Like negative, let's say negative 2. That's negative. And cube root of negative 2 will be negative. So you get positive. So when is f increasing? F is increasing from negative infinity to 0 and 2 to infinity. And f is decreasing from 0 to 2. Now f will have a local maximum at x equals 0 because f prime is, sign of f prime is changing from positive to negative. And local maximum value will be f of 0, which is going to be 0. When you plug in 0, you will get 0. Now what about local minimum? Local minimum occurs when x equals 2 because f prime changes sign from negative to positive. What is the local minimum value? It will be f of 2, which is 2 to the 2 over 3 power times negative 3, which is the same thing as negative 3 cube root of 2 squared, which is 4. So that is the local minimum value.